Aloha and welcome. In this lesson, we're going to be talking about port security. And when I say port security, I don't mean like down at the docks. I mean right here with your switch. These are your ports, and that's what we're going to be talking about here. How to keep these things secure. Well, we've got three main ways of securing them. One is we can disable them. You can go into the configuration and you can disable any one of the ports. You can also set up MAC filtering. MAC filtering is going to check whether or not the connecting device has the proper MAC address, and it can filter out ones that don't match. Do note that you can get around that through MAC spoofing, so that's not an ironclad way of determining whether or not that person should be connecting or that device should be connecting. We also have what we talked about earlier, IEEE 8021X, and that's a protocol for port-based control. So that's going to allow the device to connect to a network port only after it authenticates the network. So it's going to force it to authenticate to the network, then it's going to let it do what it wants on the port. Well, not do what it wants, it's going to let it connect on the port. So one thing that we have to worry about is network loop prevention. So let's say you have a number of switches that exist. Let's say you have one of these over here, another one over here. Let's say you have a computer here in the middle that's connected to both of these. One of the problems that we have is we could get into a situation where we have a broadcast storm or a network storm. And that's going to happen when you have multiple when you create a loop through your architecture there, your network architecture. So one thing that you want to do is you want to prevent these broadcast storms. So use broadcast storm prevention or storm control. And that's the act of preventing or reducing the packet rebroadcasts on a LAN. So you don't want to have a situation where you have a client that's sending out things that go to switch A and switch B. If there's multiple paths to a destination, you can have situations where you can create these broadcast storms. So we're trying to prevent those, and we can do that through disabling ports to reduce the extra links that we have between destinations here. One thing that's used to do this between switches, you've got something called the Bridge Protocol Data Unit, and that's the BPDU. And that's a packet that's exchanged between switches on a local area network to detect the network's loops. So it's used by the spanning tree protocol to try to create this loop-free topology for a LAN. So in order to do that, you're going to have a switch sending these packets to another switch. So one thing you need to be careful about is an attacker can go out there and try to manipulate this layer 2 traffic, the MAC address level, traffic, on a switch. They can try to inject these BPDU units packets in there and try to modify the network topology. So we want to prevent that, and you can do that by using a bridge protocol data unit guard, and that's a control mechanism that's going to prevent those packets from entering a switch port. So essentially, keep in mind that this is happening at the layer 2. So the BPDU guard, it protects against a layer 2 SDP topology attack. So that is the thing to remember there. Also, we have another type of attack, which is DHCP snooping. So DHCP, if you think about it, DHCP, if you're thinking about it, it's layer 2. But DHCP, you're thinking, well, that's assigning, well, first of all, let's talk about what it is. I've mentioned this in previous videos in class, but DHCP is a dynamic host configuration protocol. And that's where it's a network management protocol where you're assigning IP addresses and other network configuration parameters to somebody. So when you connect on your network, and you don't have your IP and everything set up manually, in order to work on that network, you need to get an IP address, you need to have your subnet mask, you need to know what your gateway is, a DNS server, things like that. Those are basic things that you have to have in order to communicate on a network. So this DHCP server, what happens is you're going to connect, you're going to send out a discovery request, but you're sending this out on the data link because you don't have an IP address yet. So you're not on layer 3 yet on network. You're talking about what's happening here on data on the MAC level. So the physical level. So you're not the physical, but you're working at layer 2. So you're going to send out this request on layer two that's asking, hey, can you give me an IP address? So the DHCP server that's out there, it'll go ahead and it'll send you your information. It'll give you an IP address, your subnet mask, your LAN or your gateway, and your DNS server. So it'll send you at least those four things. There's other things they can send you as well, but that's the basics that they'll send you. Um, so why do we do that? Because it greatly simplifies management of a network. You can set up what we call a range. Well, you can basically set up a scope for a DHCP server. Scope is like a range of IP addresses that you can use. So private addresses you can have like 10.0.0.10.0.0.1 or 10.0.0.0 can be your network, and you can have this DHCP server simply hand out IP addresses on 10.0.0.2 through 10.0.0.254. So it's going to send out these IP addresses to whoever connects the network. So you've got a number of IP addresses to work with there. So that's essentially what a DHCP server is going to do. One problem that we have is we can also have people trying to attack that. So we can have something called to prevent against somebody from putting a rogue DHCP server into our network. We can do this thing called DHCP snooping, and that's a layer two control. So layer two, because DHCP is acting on layer two here. So it's a layer two control for preventing an unauthorized or rogue DHCP server from offering network configuration parameters to a DHCP client. So it's enabled on the switch, and that connects the client to the DHCP server. So the DHCP server classifies the switch's interfaces into trusted and untrusted ports. So a trusted port only receives data from a network. Traffic from a DHCP server is allowed to be received on a trusted port. An untrusted port only receives traffic from client devices. So traffic from a DHCP server is not allowed to be received on an untrusted port. So that's how you keep that. So this is DHCP snooping, and that's going to help prevent rogue DHCP servers out there. So as I alluded to, we have a couple different DHCP attacks that can happen, and DHCP snooping is going to prevent these. The first thing you've got is the DHCP spoofing attack, which is where an attacker is going to put a device on your network. It's going to act as a rogue DHCP server. So what it's trying to do is it's trying to, whenever it hears a discovery, a DHCP discovery where somebody's asking for an IP address, it's going to try to send them forged DHCP response. So it's going to say, hey, here's your IP, here's your subnet, and then it's going to direct it to go through it. And this is going to set up a man-in-the-middle attack because they're going to have the traffic going through them. So the DHCP snooping is going to prevent that. Also, you have the DHCP starvation attack. And whenever you hear starvation, just know that what it's going to do is it's going to try to use up all those IP addresses in the scope. So when I mentioned the scope earlier, you've got that range of, let's say, 254 or 200 and whatever addresses. It's going to try to go out there and send you requests for all those. It'll spoof a MAC address, ask for it. It'll get all the IP addresses that are available. And now when somebody else, a legitimate user, tries to use the network, it's not going to be able to because there's none left. There's no IP addresses left in the scope. So they'll get, basically denied service. So this is considered a denial of service attack. So that's it for this lesson. We've talked about port security. We talked about disabling the ports, filtering from MAC addresses, which isn't 100% safe because you can spoof your MAC address, and IEEE 802.1.x, which is a protocol that makes them authenticate to the network before they can get access to the port or use the port for connecting to other things. We talked about network loop prevention. We don't want loops in there because we can have broadcast storms. So we try to do broadcast storm prevention or storm control, as it's called. We use bridge protocol data units between switches in order to keep loops from happening, but we have to be careful. We want to use a guard on that because we don't want anybody like attackers being able to use a BPDU to go in there and try to modify the network topology. And then furthermore, we've got DHCP snooping. We talked about DHCP servers. We talked about snooping and how snooping is going to prevent the two main attacks, which is the DHCP spoofing attack and the DHCP starvation attack. So that's it for this lesson. If you have any questions, feel free to reach out. I'm happy to talk to you about it. Have a great day. Aloha.